this. Lots of stuff to do today, guys. We've got the presentation stuff, the schedule wise here. So let's go. We have 35 minutes left here. So first of all, schedule. We're going to finish up 4.4 today, I hope, after we go and do the corrections on the test. Next week is going to be the rest of chapter 4, and we do have lots of stuff to finish up before end of semester. So the Monday afterwards, we just do one day to review. You guys bring in any homework questions you guys have. We're good. We take a little test to determine your grade for chapter 4 on Wednesday. And then there's no school on the 5th because we are in a what? Virtual retreat. Woohoo! And then so that made a little damper on a few things here. First of all, is those presentations, which we'll talk about in just a little bit here. Okay, so I'm going to try to figure out how to you guys submit them. I'm not sure how to do that. Okay, but we'll figure out a way to do that. Maybe a Zoom call. Well, that might work. Something like that.
That would be a very interesting idea.
It would kind of suck, but it would work.
Yeah, just because of time. And or is there a way to video on a phone and then just send it, or is it? Or do you guys want to do that?
I would not so we don't have like all the downsides of the live. No, because then you get to
So-
watch it afterwards. But then you don't have all the downsides of the live.
You don't have to watch it.
If you did a good
But
job, then
you
just
do.
don't watch it.
Uh-huh.
Unless you know you messed up.
You don't
So-
want, you don't want it to exist other than that one instance. You do not want it to exist anywhere other than that one instance.
So the final is on the 10th?
Final is on the 10th, the last day. Yeah. Then also the other thing is we don't have enough time to do the verbal final as well, which is something I wanted to do. So we're gonna have to do that only second semester.
Wait, no, what?
Grant, real quick here. So there's final should consist of two things here. There's a written final, right? And then there's a verbal final, which is consists of certain questions you guys have to memorize and present, but we don't have time because we're running out of time. So we are only going to do a written final. Shucks, can't torture you more. Bummer. So I'm thinking about this here. I'm thinking the presentations, because I do want you guys to do those. Maybe we can get a schedule going next week on like on a Tuesday or Thursday. I will have just time slots. I will set up a Zoom call. You come in, you present your stuff, and then you're out. We good? I think that'd be the best way, and then we'll go from there. Okay. So I did want to. So there's a schedule. I think that'll be the best way to do it.
So what happens if we don't finish chapter 4 next week?
We are going to finish it, and the reason for it is because if we don't finish 4.5 on Monday, like let's say we'll have 3 or 4 problems left, I'm going to go home and finish the video for those. So just those pieces. We do have to finish, or else we're not going to.
Time for like homework questions?
Yeah, the Monday right over here, you guys bring in as many homework questions as you like right over here. It's going to be a day just to do any and all. Okay. So yeah, I do want you guys to have that time here. I will give you guys a final review as well. So then on 8th, we come back, we just spend a day doing the final review. Any questions you have on that would be presented then. We're good? So I don't want you guys to do a test here. So then we're just gonna take the final exam on the 10th. Okay, we good. And then no school on the 12th and no school on the 15th. And then we come back a week later to start second semester. Okay, schedule wise, are we good?
Yeah.
Okay, let's jam to the presentation. So here's what we're looking at. This is for the algebra class. It's almost the same. We're good. So it is something for you guys as students to connect to what you guys have been learning in class. You connect it one of two ways. You connect it into something that is connects to something that in your life that you do, that you're a part of, like that you see, like, oh, that is so cool. I never noticed trigonometry in this aspect before. Okay, that's kind of thing. The other part, instead of relating it to life itself, you just dig deeper into a subject that you found interesting while in class. So maybe the whole concept of the sine function. Where did the names of sine, cosine, tangent, cotangent come from? That's more like a historical thing. Like I want to dive into that. The first thing we ever covered in class was the Pythagorean theorem. So there are actually 34 different proofs for the Pythagorean theorem done by one president of the United States. Yeah, he holds the original, one of the original proofs for the Pythagorean theorem. If you just want to delve into it, like that would be actually kind of fun. What was he thinking? Playing with math, that's crazy. So we go into it here. So does it relate to anything that you have thought about it? There's really anything in art, music, sound, astronomy, board games, computer coding, anything that you sort of saw like, oh wow, I never noticed this. As we've been covering the sine cosine function, I hope you guys noticed it's just a sound wave, right? So we had a student last semester. She brought her violin in and she played it. And then she talked about how all these different variations of tone come into play to make a sound. And so when you do a digital copy of that sound, is not as rich because the digital sound does only one only. And then, so that's why you have, it's called, it's different. So that was kind of cool. I did want to share with you guys some other ones here. I think it's right here. We're gonna look at some other students from way back when, last year. So just to give you an idea, we good? Oh, is this on? Okay, let's see. I'm gonna find somebody. This is me, younger. So, and this is second semester stuff because we were on Zoom second semester last year. And so this is a Jean. Anybody remember Jean?
Yeah.
So what she did is she did de Moivre's theorem, which we'll cover in second semester. But she just went into a history of who de Moivre was, what did he do, other books that he published, and then gave a quick synopsis of proof that she found interesting that he did. That is so cool. Okay, connected to part of the class. We're good? That's kind of going into something deeply. Let's see. Christopher Dole. Anybody remember him? Know him? He looked at, again, this is all second semester, so it doesn't relate as much here. So elliptical orbits and Kepler's first law in trigonometry, how do those come together? And how do we measure orbits of planets based upon this whole concept of trig? And that was cool. And I think last one here, just to give you an idea. Oh yeah. Who is this? I forgot who this is. Come on. Skateboards and trigonometry. How about that? It was, and how you turn, what's the whole concept, what constitutes a trick board as opposed to a plane board, and all the different angle measurements that it's made. Anyways, but does that give you guys at least a flavor of what it is? And if you guys can put on PowerPoint, that's probably the easiest way because everybody's sort of familiar with PowerPoint. And we have a rubric. I kind of made it so that.
Can we do it on Google Slides?
Yeah.
Sure, absolutely. Google Slides work just as well. And yeah, name. I'm going to jump to it here. Trig presentation. All right, it's the new rubric. All right, and as you guys find out, and as we found out, it's really tough to get a 1 if you want to rise to the challenge to try to get that one. But for the most part, the rigor of it has to be there. So it's about a high school level rigor, right? Like you really explored something in depth here. The key concept was presented, voice delivery was well, and transitions were not choppy, but actually smooth, and you kind of kept the flow of it going here. And then the eye contact was there as well. And the presentation of the PowerPoint or Google Slides, it was well made. It wasn't put together last minute. Not that we would ever put something like that together last minute.
Yeah, I don't know why you didn't say that.
Right. Okay, are we good? Is that enough of a idea?
How many slides about?
I figured maybe not more than 5 minutes of a presentation. I mean, but as long as you cover the topic and you've covered it well, so no time limit. This is kind of you saying, hey, I've explored this and look what I found. This is so cool. Okay. Does that make sense, man? Okay. The other thing is, if you guys can tell me your idea, I'll just verbally say yes or no. Or if you want to email it to me, that's fine. The only thing is I don't want 6 people doing the same thing. That's the only issue. Good. And then, so Ame, you want to say your idea real quick here?
Oh, yeah, sure. I think I'm gonna do mine on how we talked about in class that there's not many uses in life for the cotangent curve. Or equation. So I'm gonna talk about kind of like why it's not used much and then find some examples of where it is used and explain why it's used in this situation.
Cool. Yeah, and that's perfect. That interests you and you want to explore it, dive into it. Absolutely. That'd be cool. Can't wait to hear the applications because I just might use those next year. All right. Okay, we're good with that. Next on the list is the test. So test corrections out. Let's jam through it here. I put these on a quick slide so we can go through them together. And right now I'm going to actually pause the video so my answers are not everywhere. All right, so switching gears real quick here to 4.4. We are still in 4.4. Hopefully finish up 4.4. And if you guys can have your, let's see, test on top, the corrections underneath it. We're good? And then you'll just hand it in to me right at the end of class. So we have this one right here, the last one we did, which was a toughie. Example 3. What do you guys say, toughie or not a toughie? I think it's 4.4. 4.4.
Oh, 4.4, what we're talking about right now.
Yeah, the last one that we did in class.
Yeah, that got.
Got a little bit hairy. Okay. And so please ask me the question. If you really get stuck on the homework and stuff, I don't mind doing just a quick video, sending it out as well. You know, if you really are stuck, like I'm done. But this one incorporated, this was the end of the tangent ones. It incorporated everything: vertical stretch, vertical shifting, phase shift, and a period change. That's about as deep as you get right there. Okay, with the time left, let's jam to exercise 4. And I want you to graph this one for me. Now, cotangent, I guess we should say this. I'm gonna skip a little tiny thing in there. So for sine and cosine and tangent, what we normally do, we have to go directly to the graph. We got to know what the graph looks like, and then we do it. We're good? For cotangent, also the same thing. We do what the graph looks like, so I'm just going to put directly here. All those 3, you got to know what the original graph looks like, and then start from there. For secant, cosecant, as we'll do in just a bit here, those actually go back. Oh, I shouldn't actually do it this way. Those actually go back to the sine and cosine curve. So for cosecant, we go back to the sine curve. For secant, we go back to cosine curve. So that's why we don't spend too much time on it, because we're just graphing the other one here. So the other cotangent, here it is. The first thing we look at is to see if we have a negative inside multiplying our x value. Yes, we do that. Well, -1/2 is a problem. So in our minds, we say to ourselves, cotangent, even or odd? What do you guys say? It's an odd function, yeah. So let's label these guys as well here. So sine is odd, tangent is odd, cotangent odd, cosecant odd. So the only even functions we have are cosine and its reciprocal secant. Those are the only ones. Everything else is odd. So for odd functions, in order to get rid of this little negative, what we do is we have to put it out in front. So we technically are going to graph this guy.
Wait, what does that say, direct? Up in the,
Directly,
oh,
So you do have to know what the graph looks like in order to graph it. Okay, so let's go back. Let's think about what does a cosecant curve, I'm sorry, cotangent curve look like? I think it has a asymptote at 0. It comes down like this. And this is pi. Hits at pi over 2. Pi over 4. Are we good? So though that one we do have to have memorized. So now you guys talk to me here. What are the changes we got to do? Grant, what do you say?
Great question.
Super cool question. So out in front, the number in front, that's multiplying cotangent. What does that change? It used to be called amplitude with sine and cosine, right? It gave us how far it stretches up and down.
Now it's called vertical stretch. Oh, yeah.
Vertical stretch it is. Now, Grant is never going to forget that again.
I probably will. I just want to see the height thingy. Why did they change the name again?
Say again?
Why did they change the name, like amplitude?
Sure. So amplitude, it has to do with Adrian's question is why don't we use the word amplitude anymore? In sound waves and electrical currents, amplitude. But amplitude has this idea of it just goes up and it comes back down. And you have this little oscillation, we call it oscillation curves. For these guys, notice it's not an oscillation curve. It goes up to infinity, down to negative infinity. There's no oscillating.
So why do things call it vertical stretch in the beginning, if they're gonna change it?
I don't know. I almost want to say because it's so heavily used in my theory, just because of knowing, I think it's applied so many times that the word just got changed to amplitude because that's exactly how we use it all the time in every single application. So then it sort of came back to, hey, let's use the same word that's always used in applications.
Wait, so vertical stretch is amplitude?
Vertical stretch is amplitude.
The one where it's like you go up to a certain number.
Exactly.
And then
It's the
that's
height
the one.
thingy.
Yeah.
Mhm. All right, the 1/2 in here, that controls your period. We good? And for tangent and cotangent, it's always pi divided by b, and that's our b value right here. For sine and cosine, it's 2 pi, right? There's a longer stretch here. So in this case, this is going to be pi divided by 1/2. How about multiply both sides by 2? The denominator cancels, and we're left with a 2 pi being what we need to do. I'm going to go just a little bit faster because I do want to get the other one in. So vertical stretch of 2 and a period that is now shifted to 2 pi. So at pi over 2, the original graph hits 0. And we also know at pi over 4, it's going to hit a 1. Is that right? That's when it hits 1. At 3 pi over 4, that's when it hits -1. So there's your 3 dots. We call them critical points. Those are the points we have to get correct for the graph to be correct. So now let's set up our graph here. So we have a vertical stretch, so we know it's not going to go hitting 1 and -1. Now it's going to hit 2 and -2. We're good there. Because Grant told us that was a vertical stretch.
The height thing.
The height thing, yeah. Okay, now the fact that our period is now stretched out to 2 pi. So that means our next vertical asymptote is at 2 pi. The first one that does not change along the y-axis, that's still at 0. And so now we have to stretch this out. So if you think of your x coordinates right here, because our period has doubled, all we're going to do is we're going to just, in a sense, double those coordinates. We're good? So pi over 4 times 2 gets us 2 pi over 4, which gets us pi over 2. Are we good? Even a more easier way to do it is, since we have this sort of set up and it's chopped up into 4 pieces, all we do is we say, okay, half of that's going to be pi. That's my 0. Half of that's going to be pi over 2. We good? So it's a matter of either you can multiply each of the x coordinates out, or you can just break it up into 4 pieces again. So this is pi over 2, this is 2 pi over 2, this has to be 3 pi over 2. I think we're done. Let's put our dot at pi over 2, 2, 3 pi over 2, negative 2, and we're good to go. So then we come down like this, and done. Notice it's the same exact graph, again, just doubled in size, vertically doubled in size horizontally. Okay, got 2 more minutes left. I got to do the next one here real quick, and then we'll be finished with 4.4. So exercise 5, and we're going to graph y is equal to 1/4 secant. Let's see, should I do? Let me see. I'm going to do 2 instead of 1/2 here. Okay, if I can get the right, there it is. 2x. Okay, for secant, cosecant, we're going to go back to its trig form. So that is the reciprocal of cosine, is that right? Secant goes back to cosine. So what we're going to do is we're going to think about cosine being here. And that's the way normally we do it, so we don't have to memorize 6 different functions. Can we graph this guy? And then what we're going to do is we're going to just turn it onto its reciprocal. So cosine, I think we can do it right away. Can you guys do it right away? Just one period of that. In fact, without doing anything else, can you guys graph 1/4 cosine 2x in a minute or less? So amplitude now, right? Amplitude is 1/4. And our period is 2 pi divided by 2, or just pi. Okay, and then as you graph it, don't do a line graph, do a little dot graph, right? Because that's not the end one. So I'm thinking 1 is here, -1 is here. It's only going out to pi. So I'm going to break this up into pi over 2, pi over 4, 3 pi over 4. Here's 1 period. All right, and whoa, and we do have to finish up here. So I'm going to go like this. Tell me if you guys have the same graph as I do here. I'm about 1/4 high here. This is cosine, right? And I'm going to go about 1/4 low to 1. And then I'm going to stop. Is that cosine there?
Period is 2. Oh, wait, no, it's not.
Here it is. Okay, we good? Okay, here it is. To convert back into secant, all we're going to do, anytime you hit a 0, that's going to be our asymptotes. That's going to be an asymptote there. We good? So any zeros become asymptotes. Any high points, that's going to be your point to go off and take the reciprocal of it, which is going to go like this. And any low points are also going to be the same thing. It's your bottom value. That's when the 2 pieces connect, because the reciprocal of that value is going to be that. And then we have ourselves this guy here. So this is just one cycle, right? It does go on forever and ever if we like, but there it is. And we got to stop because you guys have to go to your next class. If you guys can just drop off your exams and corrections right here on the way out, we'll go from there. All right, have a good weekend. See you guys on Monday. And of course, you guys are going to look at 4.5 just kind of briefly, just to sort of see. And I'll give you some.
Mr. London, do you want me to wipe down the desk? Yeah.
I'll do it myself. That's fine.
Are you sure?
Sure. Bye.